Hi everyone, my name is Claudio Cappelli. I'm a postdoctoral fellow of Rory San Martin Lab, and I come from the Universidad Austral de Chile, from Chile, and I want to speak about my poster, which titled The Induction of the 5' ectonucleotidase CD73 by profibrotic TGF-beta signaling during diabetic nephropathy. As a background, adenosine it's one of the metabolites that is overrepresented in patients that suffer diabetic nephropathy, but not in patients that only has diabetes. So adenosines make a point of inflection between the diabetic disease and its complication that is the diabetic nephropathy. So we try to understand how this high level of extracellular adenosine that can be found in plasma and also in urine are produced. So we first point our investigation aim to the CD73 enzyme, that is the ectonucleotidase enzyme that I mentioned it in the title. That is the enzyme that converts AMP to adenosine, and so it's the limiting step between the production of between the MP and the production of adenosine. So first of all, we try to understand how the transcriptional level of CD73 can be affected by a profibrotic stimuli in a diabetic environment. So we treated HK2 cells, which are derived from proximal tubule epithelium, from human tubule epithelium, and we treated them with a high glucose condition and also TGF-beta. So we can find here in the treatment that start from 50 minutes to 7 days that at transcriptional level, the CD73 mRNA increase after 6 hours of treatment with TGF-beta in high glucose condition, and reaches stop after 48 hours of stimuli, and stabilize it through 7 days of treatment. So we can say that the principal is upregulation of TGF-beta at the CD73 mRNA occurred at 6 hours and reached its highest point at 48 hours. Parallel to this CD73 increasement, we also found that TGF-beta, fibronectin 1, PEA1 gene are also upregulated, which are well-established fibrotic markers. So we can say that CD73 it's early upregulated in a diabetic nephropathy environment as other genes that are well described. At protein level, here figure 1E, we can see that the upregulation that we observe at the transcriptional level, it's also accompanied by the increase in the protein total quantity in the cells. So next we move out to understand if this increase at transcriptional level and protein level of CD73 are represented in exposition of this protein in the outsider part of the membrane, where it is functionally active, and we try to understand that if this occur, using two strategy. One is cell cytometry, flow cytometry, and the other one is indirect immunofluorescence. What we found here, it's resumed in figure 2A, in figure 2B, especially more specific in figure 2A, we observed the result of flow cytometry experiment that indicated that when the H2Q cells are exposed to TGF-beta and in high glucose condition, we observe that only in this last one condition, that is high glucose, we observe an enriched number of HK2 CD73 positive cells. Moreover, this increment in the subpopulation that expose this protein in the outside, there is an increment of the relative fluorescence of this cell. So these cells export, in the presence of TGF-beta, export to the outside on the membrane more CD73 protein than the cells that are only treated with high glucose. Moreover, in the figure 2B, we observed that CD73 staining is greatly increased in cells that are being treated with high glucose condition, and more evidently in cells that are treated in high glucose condition with TGF-beta, and this is occur in parallel with fibronectin 1 upregulation also at the surface of the cell, because we made the experiment without using detergent, so we did not let antibody get inside to the cells, and we are only detecting superficial antigens. So, moving from the cell membrane to the nucleus, we want to understand how transcriptional level and upregulation of the CD73 occurs after TGF-beta and high glucose stimuli at the chromatin level. So we make a study of the CD73 gene promoter, and there we found that there is a SMAD binding element motif in the proximal promoter. We designed primer over there, and we try to detect transcription factor, canonical transcription factor derived for TGF-beta stimuli that are SMAD protein by cheap qPCR strategy. And what we found is resumed here in figure 3. We observed that after TGF-beta treatment, as we can see here with positive sign, it's able to induce the occupancy of the SMAD2, SMAD3, and the phosphorylated form of the complex, which is transcriptionally active, at the promoter, but only when the cells are treated with TGF-beta, independent if they are treated in high glucose or low glucose condition. So TGF-beta stimuli by himself is enough to make to target the transcription factor to the promoter of the CD73 gene. Moreover, we found that also P300, it's a protein that active transcription are co-localized with the transcription factor at the same region of the promoter. And this localization of transcription factor and transcription regulator, it induces change at histone composition. And here in figure 3, E, F, G, and H are assumed the results for 3 histones modification at histone H3 histones. And we found that active transcription associated histone mark are upregulated after high glucose and TGF-beta condition in response to the occupancy of the transcription factor. And on the other hand, the histone modification that are related with repression of transcription are decreased after our treatments, indicated that the transcription factor that reach the promoter of the CD73 gene or NT5E gene promoter induce change at the chromatin level that can explain the change that we observe in transcription levels. Finally, we try to find if our CD73 upregulation that we found in cell lines is also foundable, or we can find the same biological conducts in patients. We established a cohort of controlled diabetic and diabetic nephropathy patients, 10, 98, and 10 respectively patients, and we purified from those patients extracellular vesicle from the urinary sediment, and we make assay of Western blot assay to those extracellular vesicle purified, and we found here in figure 4b that the extracellular vesicles are highly positive to CD73 mark. As we can see here, there is 3 bands corresponding to 3 patients assayed, and we cannot see any band at healthy or only diabetic patient, indicated that CD73 upregulation is specific and for patients that suffer nephropathy in a diabetic environment. Moreover, we found that in those extracellular vesicles isolates the activity as an enzyme of CD73 as an MAPase is also upregulated only in diabetic nephropathic patients, indicating that CD73 is one of the targets of the profibrotic stimuli that diabetic patients suffer. We can find that at proximal tubule cells and also urinary sediment that the CD73 is upregulated as a protein, also its activity is upregulated, and the establishment of epigenetic program to induce its expression could be all of them used as a future marker of CD73 in the clinical as an indicator of an early fibrosis progression in diabetic that are in patients that are diabetic nephropathy. Thank you very much for your attention.